Good afternoon, everyone. Welcome to the session, ArcGIS Runtime SDK for Android, Building Applications. I'm Rama Chintapalli. I work as a product engineer in the Runtime Android team. And today, I have my colleague Trevor with me. Trevor, you want to say hi?
Sure, if I can figure out the audio-visual equipment. I'm a product engineer on the Android team. I work a little bit with Rama, mostly on documentation and samples. So if you find any bugs in the sample code, that's my fault. Yeah, that's me.
So before getting started, I just want to ask a couple of questions. How many of you already used Runtime Android SDK before? Okay, so that's quite a few. And how many of you used Kotlin for Android development? Okay, 3-4 people. That's still good. So let's get started. Let's see the agenda for today's session. Okay, so that's the agenda for today's session. We'll have an introduction on how to get started with the SDK. Then we'll talk a little bit about the developer patterns, which are really fundamental to work with Android SDK. Then we'll see a functional overview of the SDK, how we design things so that it's easy to understand. And then we'll also show some SDK components. We'll go through some open source apps and examples through the samples and see the various SDK components that we use to build those apps. And then finally, we'll talk about some of the latest or new SDK features that we are providing. So what exactly this session is going to help you is to build ArcGIS Android apps. When we say ArcGIS Android apps, what we mean is we do have some in-house ArcGIS apps like Collector, Navigator, Workforce. So those are all the apps that are built using the Runtime Android SDK. And if you are looking to build an app that is similar to that or any other app that helps your organization to kind of help you with your workflows, then Runtime SDK is the starting point for you. So how do we get started with the SDK? First of all, you can register with a developers.arcgis.com account and sign up for free. You get some credits, you get some premium content that is accessible to you, and then you get all the web and native SDKs along with it, so which you can work with. And the next step would be to go and install the Android SDK and the Android IDE. And Android Studio is the default IDE that Google recommends for developing Android applications. So you can go to the Android website, download it, install it, and then you can install the Runtime Android SDK. There are a couple of ways you can do it. You can kind of configure it in your Gradle file, or you can download the SDK directly. As I mentioned, when you log into your developer's account, you'll see all the SDKs there where you can manually download the zip file and use it. So when I say you can kind of configure the SDK within your app through Gradle, what I meant is because we host our SDK as an Maven repository on Bintray. So when you create your first mapping application, if you go to your project's root folder, you will see a build.gradle file where you can just go and add the Maven repository over there, and then you can add the dependency of the Runtime SDK and point the version that with which you are working. We maintain all the older versions as well, so at any point you can use any version that you want to work with. And yeah, once you have this configured in your app, this automatically downloads the SDK for you when you are packaging your app. Or the other way, which I suggested, is if you are downloading the SDK, then you can use those individual native libraries or the API jar file on your own, and then plug them into your external libraries and then package your application. So now that we have seen how to get the SDK, let's see how simple it is to create an mapping application with the SDK. If you are creating an Android project, you will have the default layout in the resource section, and you can just open the layout file and add an map view component to it. And then on your activity, all you need to do is just create an instance of the map view and create a new map object. You can specify the base map that you want to use, center it wherever you want, and the level of detail, and set the map to the map view. That's it. It's as simple as that, and probably you need to give permissions to access the internet, just like any other Android project. You can do the same thing in Kotlin as well. It's pretty much the same model. It's quite easy, and we provide support for both Kotlin and Java, so it should be straightforward whether you're working with Kotlin or Java. And that's it. Once you have the app, you can just run it through the Android Studio and install it on an emulator or a device, and your first mapping application would be ready. So that's the starting point to create a mapping application. But like, what are the other resources that we provide for you to kind of extend your app to the next level, the kind of functionality that you're looking for? We provide a lot of SDK resources. We have the developers side, which is the developers.arcgis.com, where we provide the guide doc, and we conceptually explain each of the concepts of the SDK there clearly. And we also provide an API reference where you can go and search for any of the classes that we use, any methods with proper documentation. And we also give details about the samples, how each sample is designed, or like how it's going to work, where to get the data from. All those details you can find on developers.arcgis.com. And we have all the source code for the samples available on GitHub. So somebody can, both Java and Kotlin samples are available on GitHub, so you can go download or fork them and work with them. And if you find issues, you can just report right there on the GitHub repositories. We also have a GeoNet community where you can, like, if you are stuck with any problem, you can report to us in the GeoNet community, and where a lot of Esri staff respond, and also like there are other developers who are using the SDK, they also respond there on the GeoNet community. So we have a few more SDK resources. As I mentioned, we have the samples in GitHub. But sometimes, like, to fork and run the samples, you need an IDE and to see what the sample does. But in order to simplify that process, we have a sample viewer app where you get all the samples kind of categorized by their functional areas in the sample viewer app. And this sample viewer app is available in Play Store. So you can download it right away and see what kind of samples we have. And interestingly, the sample viewer also kind of lets you see the source code of what we are doing just on your mobile app without even having an IDE or downloading or forking the samples. We also have Dev Labs, which is kind of relatively new, but it's a good set of step-by-step instructions you get in the Dev Labs if you're interested in trying to understand a particular functionality and how to get running with the SDK. And finally, we also provide open source apps. So open source apps are slightly the next level to the samples that we provide. Typically, there are multiple components of the SDK that are bundled, and like nice working app is created where we follow some of the modern design patterns of building applications in these open source apps. And these are completely, as the name suggests, they are completely open source. You can view the complete code of it. Again, they are also available on GitHub, and you can find them on developers.arcgis.com. So these are some of the open source apps that we provide. For example, there's a Maps app, there's an ecological marine unit, there's a nearby app which kind of shows like mapless pattern. So if you're working with, you can still work with the SDK where you don't work with a map, but you can work with other components of the SDK and build apps such as nearby. And you can actually contribute if you have an idea to an open source app, or like something that you think you built really on yourself, and which you think it would be cool to put it out. You can always approach us. We can take care in like trying to put that on the example or the open source apps. There are a few more apps which are going to come through the open source. We are planning for a data collector for Android, which is different from the ArcGIS collector, which is like slightly a minified version of collector on Android. So that source code would be available for users. And when we talk about Android, we definitely need to talk about the CPU architectures, because the Android comes with a variety of CPU architectures that you have for the devices on field. And currently we support ARM v7 and x86 architectures, and coming 100.5, which would be the next release around April timeframe, we will be supporting the 64-bit native libraries, which is a requirement for apps that are being published onto the Google Play Store. So if you have an app already with 32-bit libraries, the Google is going to restrict that app if you don't include the 64-bit libraries in your app that is published to the Play Store. So that deadline is August. So you will have some time from April to August to kind of upgrade your existing apps and republish them to the Play Store. By default, when you use the SDK, since we have this multiple native libraries, if you by default use the SDK and then bundle your application, your APK size is probably going to include all the native libraries, and your size of the APK might be too big. So the workaround for it, or not the workaround, or the recommended workflow is to kind of use filters for your native libraries. You can go to the root project of your folder and go to the build.gradle file, and you can specify the ABI filters, which native libraries really you want to use. And also the Play Store allows you to submit multiple APK configurations for different device configurations that you have. So that's something you can read more on the Android page, how to do that. So yeah, with that, we will probably move to the developer patterns. Trevor is going to talk about some of the developer patterns that we follow in our SDK. Sure.
Thanks, Rama. So in coming up with the slides today, Rama and I had a discussion about what would be one of the best ways to kind of get everybody on board when they're starting to develop with our API. And by using some of our developer patterns, which are interfaces and implemented on many of our classes in our API, by learning these patterns, we're going to go through 4 today. You're going to be a long way towards understanding how our API works. So the first developer pattern we wanted to go through is called the Loadable pattern. And the loadables are responsible for loading resource metadata asynchronously. And it's implemented on a series of different parts of our API. We've got about 20 layers in 100.4. That's up to 25 in 100.5. They're all working with the loadable interface. Maps and scenes, the classes that are responsible for holding and displaying our data, they're loadables. Portals, tasks, a lot of classes that have to do with remote resources. All sorts of disk I/O, data processing, they're all using the loadable interface. And I'm sure most of you are familiar with that term, but an interface, in case you don't know, in Java is a set of methods and properties that are inherited by any class that implements it. So, okay, everybody learns differently. I learn best with code rather than conceptual models. So I'm just going to quickly walk you guys through the loadable interface as it is currently being used on this portal. And I'm going to see if I can put the mouse on the screen. There we go. So that I can show what I'm talking about. So this is a portal. It's a loadable. It's going to arcgis.com to try to get some data. To that portal object, we're attaching a done loading listener. So this is implying that on the when that portal is done loading, let's do the following work in this new background thread. So Loadable also has a method for checking current load status. So in this if statement, I'm saying, right, okay, I know that the portal is done, but did it actually load? It may have failed to load, and if that's the case, let's handle that error somehow. Let's get that load error, get whatever message it is, and see if we can potentially kick off with a call to our retry method, or just throw an error and stop there. So I chose this example because it's actually two loadables. The portal item is also a loadable object, and it actually takes a portal, which is also loadable. So we have this thing called chaining. When one loadable is called by another, it will automatically kick off that load process. But of course, in this example, we're explicitly loading it with a call to load async. And in the event that we catch any of those messages, sorry, I meant to say this earlier, in the else clause here, we move through these 4 different enumerations for load status. Not loaded, meaning it hasn't started to load yet. You haven't called async. Loading, it's in the process of loading. Loaded, it's loaded. Failed to load. It's all pretty straightforward. So this code, what is this, maybe 20 lines of code, can all be done in this succinct fashion. And that's what I meant by saying that this is that loadables are chainable. So at the time that we set the map to the map view, we know map is a loadable, so the set map method is triggering load async on the map. Map is taking a portal item in its constructor. Portal item is loadable, so it's actually calling load async on that, and so on all the way up the chain. So all the work that you saw in that previous slide can be done in just those 4 lines by using this loadable chaining. And then this is just a conceptual model of how loaded works. It moves through the state from not loaded to loading. If it's failed to load, you can trigger a retry. If it's loaded, you can use that data however you wish. So the next pattern we're going to go through is the ListenableFuture pattern. It's used to simplify asynchronous tasks in our API. And it's implemented on things like identify, selection, translating a screen point to a map point, generating parameters, getting results from query and geoprocessing work. So you'll see it in lots of places. And just to sum up what it is, it's a promise to return a result of a certain type. And what's critical to know about the ListenableFuture is that a call to .get will block any thread that it's on. And if that doesn't mean a lot, the next slide will make it clear. So to this, in this case, we're using a locator task and calling it geocode async and passing in some parameters. And what it's returning is not a list of geocode results. It's returning a list of geocode results wrapped inside of a ListenableFuture. And because ListenableFuture includes a done loading listener, we're able to do all this work in a background thread to make sure we're not blocking that call. When we call get on that future, we want to do that work off the main thread. Otherwise, in Android, you'll see the whole thing fall over. And of course, anytime you make a call to something like get, where you're expecting some future result, we need to put it inside a try and catch block in case that result somehow is interrupted through some sort of network interference or so on. Okay, so next we'll take you on to one of our another parts of our API patterns, the ListenableList. And the reason we put this in here is because it maybe has a confusing bit of syntax. Compared to in Java, we're used to saying we'll get graphics, so we can therefore also set graphics. But in this case, on a graphics overlay, which we'll go through in a demo in a little bit, a graphics overlay holds graphics. So when you call get graphics, you're actually getting a listenable list. So if you want to add graphics to the graphics overlay, you have to first call get graphics and add graphic, and then the call to add and pass in a graphic to add to it, rather than mgraphicsOverlay.set graphics. And this catches everybody out. When I started at Esri, that caught me out. So this is just a good one to know, because you'll see it a couple times in our API on these different classes and methods. And the last one is our task and job pattern. And tasks are used on all those different places in our API, and they may potentially return a result, or they may return a job. So our geocoding tasks and our routing tasks, they'll return a result when they're done, longer running tasks like export classes, sync tasks, offline workflows. Instead of returning a result, they're going to return a job. And what that means is we have a long running task that we can use various listeners to check progress and completion. They can be started, paused, resumed, canceled, and so on. It's anytime you're going to do work that's going to take a substantial amount of time and potentially could be interfered by loss of network service and so on. So we'll just quickly walk you through the code. In this case, we're using an export tile cache task. And actually, you'll see that ListenableFuture pattern again we just saw. But when we go to actually create the job here, we're also going to add a listener, in this case, a progress change listener, which is going to give us a simple integer between 0 and 100 that's saying how far am I to finishing the job. And of course, a job done listener, where you can do something with that data once it's completed. And similar to the task earlier, which required a call to load async, you're going to have to start that job explicitly. So we'll hand it back over to Rama, who's going to go over a functional overview of the SDK.
Thanks, Robert. Thanks, Robert. That was very helpful to understand the developer patterns, because most of our the SDK depends on those patterns that we just saw. So any class that we work, you are going to use that. So we need to have a clear understanding of what the patterns are. So before actually going into the individual SDK components, we thought that it would be better to give a very high-level overview of how the SDK is, so that like it doesn't overwhelm someone when they see the SDK. There are a lot of classes, a lot of packages, so where to get started and things like that. So this functional overview will give you an idea how we separate our SDK. We'll start with the view components. So these are the view components that you will see in our SDK. And obviously the fundamental thing is the map view. The both map view and scene view, they extend from the GeoView class, which in turn is an extended class from the view group, which comes from the Android. So that's where like whatever you see is driven by the view, these view components, and the model that comes, or the data with which the model comes, is coming from the map or the scene, which is the ArcGIS map and ArcGIS scene. We also provide other view components, like callout to show a pop-up, or we have a location display to show the GPS location. So these are all, or a sketch editor to kind of edit the geometries. So we provide a lot of these components within the SDK itself, so that it's easy for you to build your applications. And as I mentioned, so the view is an important part, but the view has to be driven by some model, and those models are the ArcGIS map and ArcGIS scene. ArcGIS map and ArcGIS scene are like kind of completely portable, have a completely portable schema where you can switch them across the platform. So you can, it's the same schema that we try to maintain across the client SDKs or the services or the mobile map packages or any of the scene packages that we work with. So the schema remains the same, and it's important to know where the source of this data is coming from to these models. And these models, the map and scene, they have like layers and tables within them. And if you're working with raster data, you would be working with like a tile layer or an ArcGIS map image layer or a raster layer that's coming from a file. If you're working with the vector data or working with a feature service, you would work with an service feature table. If the same feature service, if you take offline, you would be working with the geodatabase feature table. And then we kind of support a lot of OGC third-party layers as well, like the WMS, WFS, all those types of layers. And to work with 3D, we have this ArcGIS scene layer and like point cloud layer. So these are all kind of are part of the schema of the map. And as I mentioned, this map is easily portable, So the same schema applies whether you're working with a map in a desktop or working with a map in online or working with a map in runtime. So and you can share across the platform as well. So the next set of components that are part of the SDK are the tasks. So these are like the operational components which actually drive the functionality of your SDK. Like we have a lot of tasks for, like we have the locator task for geocoding or routing tasks to perform, to solve the routes, or if to take a map offline, an offline map task or offline map sync task, or exporting a tile cache. So depending on the type of app that you want to build, you would be using one of these tasks in your application. And they would be executed on a map or a scene or a layer, depending on what the functionality that you're trying to achieve. We also have a set of components like portal, security. Like portal, for example, if you want to work with an enterprise portal or ArcGIS Online, we have a nice set of API to kind of access those resources. And in security, we kind of handle most of the security within our SDK itself, depending on the type of security that your services are configured with. We take care of everything for you as part of those components. And obviously we need a geometry API to kind of work with all the types of geometries. And for a better visual experience, we have a very advanced symbology API as part of the SDK. So that's kind of like a very high level view of the SDK. Now we'll dive into some of the individual components. So we have a lot of functionality in the SDK. So we thought we wouldn't try to cover everything. But we chose some example apps and samples that we have. So we'll go through a demo of an application and see how those individual components are used in each of these apps. So to start with, we'll see a demo of Maps app. So Maps app is an open source application. So we provide this. So what it does is basically like you can open the map, get the location of it. You can switch your base maps. You can sign into a portal like arcgis.com where you will get an OAuth configuration. Because the app is set up with an OAuth configuration, you will be prompted to enter the credentials. And then I can enter the username and password and sign into the app. Now I'm logged into the portal. I can see some of the content that I have in my portal by fetching the maps. I can actually do geocoding, or like I can find something in Palm Springs. Interesting. Let's find the Esri office. So this locator seems to be only finding the Palm Spring data. So we can do the geocoding. You can find or solve a route through this Maps app. You can see the directions provided. You get the turn-by-turn directions in this app. And actually you can go to the individual route result as well as part of this app. So there are like multiple components of the SDK that are used in this particular Maps app. Let's dive into the individual components and see what all we used. So we have seen the usage of a map and a map view in the app. We saw accessing a portal. We saw how the OAuth authentication is done in the app. We had suggestions for searching the place. We did the geocoding. We haven't seen the reverse geocoding, but the app is capable of doing the reverse geocoding as well. We solved a route, and we saw a graphic being added when we tried to do a geocode. That's through a graphics overlay. So again, to get a deeper understanding of what map and map view can do, as we already talked, that map is like the central one of the central components which consists of layers and things like that. It's not just that we provide a lot of listeners to the ArcGIS map object. Whenever the map loading is done, or the load status has changed, or like whenever the base map has changed, like we provide all those listeners so that you can do certain operations based on what is happening throughout your application, and the same map can be kind of persisted and shared as a web map and portal and things like that. Map view, again, similar to map view kind of is the visual representation of our data. So it has its own listeners. Whenever the draw status of the map view is changed, you would know that, or a layer's individual status view state, whenever it is changed, you will get to know. So we have like set of listeners on that as well, or whenever the scale of the map changed, or like whenever you rotate the map, or so you get the complete control of what you want to do in your application. So this particular Maps app is kind of using only a portion of the SDK, and we are just showing it to highlight some of its functionality. We have seen how we logged in to an OAuth portal. Basically, what is happening behind the scenes is it's managed by an authentication manager, which is like the central place for managing all of the secured resources in our SDK. So authentication manager basically is the one that lets you set the default challenge handler, or like it manages your in-memory cache for your app. Again, it manages the certificates that are required to access the secured services. And then we also have a default authentication handler, which is the UX that you would see whenever you hit a secured resource. For example, the default authentication challenge handler would look something like this. Like if you're using a token-based security, or you would get a prompt like the one that you see on the left. If you're hitting an untrusted service, you would see something on the middle. Or if you're trying to access a PKI secured service, it will prompt you to install things. So everything is part of the SDK. Like you don't need to worry about it. We take care of that. As long as you use the authentication manager and set the default authentication handler, we take care of everything for you as long as the service is secured. So there's more detailed session that is happening on how the authentication works for your apps in the runtime. That's happening on Thursday. If you're interested, you can attend that. We have seen portal API because we logged in and we tried to fetch some content, web maps through it. Again, you will see all the patterns that we discussed before. It's the same. So you load a portal, you try to fetch the content, you get the user who logged in into the portal, and from the portal user, you try to fetch the content that the portal user has permissions to access. And then we return the result, and then you can use the result to do whatever you want. So there are like some other key classes like the portal item and portal group, and there are like tons of other classes. We just want to highlight some of them to highlight how the portal API works. Same is the case with the geocoding. Again, like you saw like a locator task where you pass in a URL of the geocode service. You try to perform a geocode async method or a reverse geocode async method, which will return a geocode result for you, and then you can use the geocode result. You get the address or the position of the geocode result, and the score of the result, how much accurate it is, and other attributes that you might get with the result. And then you can work with the result and do whatever you want on your application. And the pattern is the same for routing as well. Routing has its own task. You just need to get an route service, pass in some set of route parameters, and solve the route. You get the route result, and then use the result and do whatever you want. So that's the map app. So we saw some components of how they were used in the Maps app demo. The second important component that we want to kind of highlight in this session is the offline, which is quite popular in runtime. We just wanted to give an overview of the patterns that we have in the offline scenarios, and then like you can probably attend another like detailed session on offline, which is going to happen probably a couple of days later. So the first pattern for with working with offline data is the services pattern. In services pattern, you have a feature service which you want to take, or a map or a map in ArcGIS Online, which is available, and you want to take that map offline. So there are a couple of ways that you can do. You can do an on-demand workflow where you control which area you want to download, which layers you want to include, whether you want to include the attachments or related data and things like that. Basically, the user controls whatever data that they want. Obviously, because it's a user-controlled one and they're trying to download things on demand, it's slightly more time-taking because it will take some time to cook the data and download it. So for that, to solve that, we came up with the pre-planned workflows where the admin can decide what are the pre-planned map areas that he wants to pre-build and then host them in a portal or an online environment where they already package everything into an MMPK and host it. And then the field workers can just go and download it directly. So now like they're saving the time of being like pre-cooking all the data on demand. So these pre-planned workflows are for users who want to just download all this pre-cooked data at once on the field and then just go for field collection. So you can see from an API perspective, it's the same task. It's the offline map task that you would work with. So if you want to download a pre-planned map area, you would use one method where you would pass in a map area that you want to download. If it's on demand, you would call another method like a generate offline map, and you pass in a set of generate map parameters, like the offline map parameters. The second pattern where you want to completely work disconnected, you don't want to work with any of the feature services, is through the desktop. So you can order maps as mobile map packages, which can include multiple maps within them. You can just use ArcGIS Pro or to create those mobile map packages. We provide Python tools to do that on ArcGIS Pro. Or if you want to if in case you want to work with the like full map, you can use that. But if you want to work with like individual layers which you want to take offline, you can create runtime content. Again, ArcMap or ArcGIS Pro will let you create those individual layers as a runtime content, which you can later sideload them onto your device and then access them. So there is a detailed working with online and offline maps and runtime session that's also scheduled for Thursday. You can attend that. And probably Trevor is going to show a sample of one of the patterns here through a demo.
Great, thanks, Rama. So this is another one of our open source apps. This is called the Offline Mapbook. And what we wanted to do by showing you this one is just highlight that almost everything you can do online with a service, you can do offline as well, as long as you have that data loaded on your device. So I've skipped the part which involves me typing in my password because I forget it all the time. And it would take about 90 seconds to download this mobile map package, which Rama was just going through. But that's what you first do when you start this Offline Mapbook app. It shows the 3 maps that are contained within that mobile map package. And we'll just go through 1 or 2 of them now. And you'll see that pretty much everything we were doing with the map app that Rama showed earlier with online services, we're able to do offline as well. So the basic thing you want in every GIS, be able to turn layers on and off, of course. So these layers come bundled in the mobile map package when it's loaded on the device. Zooming, panning, everything you'd expect is still there. But in addition, we've also got things like geocoding. So this is all happening with a local locator that came with a mobile map package. We can do reverse geocoding by tapping on the map. And so this is a really simple app. I'd really recommend it as a potential starting point. I'll just quickly show you the web page responsible for it. You can get all the source code for this app. It's fully architected. It's all available on GitHub. There's all descriptions about the different parts of the API being used. And so yeah, that's the offline map book. And in a second, we're going to go on to some demos just to show some of the new things in our API.
Right.
Sorry.
Oh yeah. So we again chose another important component, which is 3D. We want to showcase or highlight in our SDK. So we thought we would just go through some of the demos or functionality that we have through some of our samples and show you how the 3D works on Android. So Trevor is gonna just run through those samples.
So as Rama maybe mentioned earlier, the Android sample viewer is available on the Play Store. So you can download it right now if you want in the audience, have a play with all sorts of different parts of the functionality in our API. But specifically, we highlighted 4, time allowing. Yeah, I reckon we can just squeeze it in. That we wanted to show that's showing some of the newer parts to our API. And the one I want to show you first is called line of sight GeoElement. And this is using the analysis overlay on the scene view to tell us when a taxi moving through around a block in New York is visible from a certain place on the Empire State Building. And you can see this is all happening in real time, really performant. And what I was going to do is just show you a little bit what the app looks like. Here's a little taxi scooting around. And we'll actually go back and have a quick walk through what the code looks like on that. And that's all available within the sample viewer as well. So some of the components in this sample include, we're going to use a scene, which as we know is the thing that's holding all of our data. The scene view, which is responsible for navigating and showing that data. We've got a surface with an elevation that's three-dimensional, and that's underneath those building layers in New York City. We've got the graphics overlay, which is holding the taxi graphic, which is rendered here with a simple renderer. We've got that observation point, which we are moving up and down the Empire State Building, and a progress listener here, which is taking in from that slider bar to update the position of that point. And then a model scene symbol, which is responsible for rendering and holding that taxi graphic. And then the analysis overlay. And the analysis overlay is applied directly to the scene view, and that's what's responsible for rendering that green line, which you saw. That the analysis overlay holds that. And that line of sight object is referred to as a GeoElement line of sight. And so in not too many lines of code, we've managed to have a really powerful app capable of doing this line of sight task, and it's really quite performant. And I'm aware that we're maybe a little bit short on time. Do you think I have time to go through all 4?
I think you have.
Okay. Yeah. So we'll take another one. Look another one in the analysis group. Oops, this isn't the one I wanted. This one here. Viewshed location. So this is using that same analysis overlay within a scene view. We're using an ArcGIS scene layer to render all those buildings. I'll just give it a second for it to finish loading. But you can see in real time we can get viewshed from a particular point. We can do all sorts of things. We can change the pitch, horizontal angles, vertical angles, minimum and maximum distance. I'll just see if I can turn this around. So gives you loads of control over different parts of this analytical tool. So again, I'll just take us on a quick walk through the source code. We'll skip a lot of the stuff we've just been over, handling scene views, but the code required to change the parameters in that viewshed are actually really simple. It's as simple as viewshed set heading, set pitch, set horizontal angle, vertical angle, minimum distance, maximum distance. So with very little code, you can have this really powerful analytical tool just available to you. And in the last two, we wanted to show two things that are coming out in 100.5. These are things that will be further explored in the Road Ahead session coming up on Thursday, I believe. And so the first one is our point cloud layer. Point clouds are really a popular way to display data often taken from LiDAR, extremely dense data. In this case, it's a park in San Diego. But you can see the performance, this is all rendering locally on the device, many tens of thousands of points. And this is all coming out in the release, which is fairly imminent. So this has been looked for by our customers for a while, and we're really pleased with the result. And that source code is extremely simple. It's just a new layer, which we can see right here, point cloud layer. In this case, it's loading from locally on the device, so we just have a path to there, and we just have some code to handle any errors on that load, but it is literally one line of code to display that quite rich data set. And the last one we wanted to show was our integrated mesh layer, which is closely related to that point cloud layer. Point clouds, of course, can be difficult to look at potentially. They're, if you zoom in far enough, you'll have gaps between those points. So one of the things we wanted to bundle in with is what we call our integrated mesh layer, and that's drawing between all of those LiDAR points. And you can just see the fidelity and level of data is just really quite high quality. And I'll see if I can, sorry, my fat fingers are flying us all over the place. But you can see we can get down to really high levels of detail along this rock face and so on. Excuse me. As I said, though, you'll see more about this in the road ahead. So that ends the demo section, and we'll hand back over to Rama, who's just going to sum up the talk for today.
So we have seen some of the 3 demos for line of sight, view shade, point cloud layer, and integrated mesh layer. So we just wanted to wrap it up with letting you know what is coming or some of the new features or the coming features. So on 3D, we'll have the mobile scene packages. We are also going to have subsurface navigation in 3D in 100.5. We just saw a demo of point cloud layer, and there we are also supporting point scene layers as well. So there are tons of improvements done to the performance of our 3D across runtime. And you would see that on Android as well. For offline maps, we also included support for reference-based maps. What that means is you don't need to package or download this tile-based map on a portal environment. You don't need to host it. Instead, you can sideload that on the device, but you can just give the path where you reference this base map directly on that portal item settings. So the runtime would be able to know where the tile or the base map is on your local device because of that configurable setting that you set on your portal item. So it will find from the local device, and then it can just load from there instead of downloading and then saving time for users. So that's also coming in 100.5. So in 100.5, we'll have support for WFS, OGS feature service, OGC feature service. We already supported KML in 100.4. There's more coming to it. So we're going to support KML tools as well. Something that the utility companies has been asking for is the annotation layers. So the support for reading the annotation layers is coming this release. And we are also going to support the next generation tile packages, which is the TPKX files, and also the next generation locators, the LOZ files. We also revamped a lot of our symbology. So you will probably see kind of on par with ArcGIS Pro because we are trying to integrate the symbology model so that you get the rich visual experience in runtime as you see across the platform. Those are some of the latest or the coming features that we have. With that, just quickly wrapping up what we saw in this session. We just introduced on how to get started with the SDK. We talked about developer patterns. We also saw an overview of the SDK. We just ran through some open source apps and example apps and then talked about few SDK components which we thought were important. And then we just showed some of the features that are coming in the future releases. That's all we have, and if you have any questions, we will open the floor for questions. And also don't forget, there's an app for survey. So for questions, we're going to hand over the mic so that, because this session is recorded, so your questions can be recorded.
Hey, that scene viewer interaction looked really cool. Is there going to be any support for object return, or do we have to do some kind of frame buffer hack to know what we're selecting in the 3D scene viewer, like re-render in color scale and offline in a frame buffer? Because that's going to be a huge thing for a 3D interface, is to be able to click on your
selection or like identifying features on a scene layer.
Yes.
You've got a sample that will show that, so probably answers I'll try to pull it.
Yeah, because the identify should work irrespective of 2D or 3D. So you should be able to select features from a scene layer. So let's see if the sample shows that.
It's just quite a heavy data set rendering all these buildings, so it'll take a second to load. But you'll see each of these things is a geo element, and all I have to do is tap on it. And in this case, our samples are always really, really basic. They want to try to just highlight one small part of the API. So this is just using our highlighting to say this is what you've tapped on. But of course, yeah, you can pull any information you want directly out of it. So yeah, we can. It's already there.
Any other questions? Yeah.
Yeah, I was wanting to know a little bit more about ABI filter, how that can maybe benefit us. We're not using a lot of the SDK with our specific app, so the 50 megabyte size, if we could reduce that, I was looking for a way to do that. It sounds like that might be it. Also, do you know an equivalent for iOS that's similar to that?
Not sure about the iOS equivalency, but for Android, first thing obviously we want to check is use the APK analyzer and see whether your app is including all the native SDKs or not. So that would be the first point, because by default you should see all the native SDKs if you have just packaged it. So the ABI filter, what it does is it kind of excludes the other native filters and let you create an APK which is specific for that. But then you don't know whether your app users is going to use the same CPU architecture, because each of them might have their own Android handsets which might only work with certain CPU architectures. That's why, like the last point that I showed in that slide, where packaging multiple APKs to the Play Store is where it's going to help you. So you can create an APK with a smaller size and have multiple APKs pushed to the Play Store. And the Play Store is smart enough to show, depending on the device that the user is using, it will show only that particular version of the APK, and they can download only that.
Just to mention in the deployment section of the documentation, we have just published a document which explains exactly what you're looking for there. So talking about the different deployment methods and the ABI filters that you can put together. So that's in the deployment section. You can read all about that. We've just literally published that.
Any other questions? Yeah.
Yeah, it looked like you were doing a TIN over LiDAR in the last demonstration. Is that done in real time or is it baked in advance? The draping that you did with, you said the unlimited detail based on the LiDAR data. Did you bake that and pre-process it?
That's pre-processed or not.
It's coming from a service that is hosted in Portal.
Like the surface is a service, or maybe the draping is done as a service against the LiDAR data set.
Oh, the surface, because I think it's a scene, so you need to provide the elevation layer to the surface. That's again, it's coming from a surface, so it's not a pre-cooked surface that you're seeing.
Okay, I think I was talking about the LiDAR
The
display.
integrated mesh layer. I suspect that it's probably comes through with point data and the rendering is handled on the device.
Okay.
So there's a format of 3D data that we use called I3S. So it's the integrated 3D mesh, and it's just basically it's a compressed format that we use for storing 3D surface information, which is textured as well. So it's all compressed in that format. It's pre-cooked, and we have that in a service that you can use. But you can also create your own using ArcGIS Pro as well. So I3S is the format that we use in the format. That's just an open format that we make use of.
Yeah, but the data is coming from the service. Yeah.
Just on the services pattern for the offline, is there a way to get the locator and network analyst data down locally?
Not through a service yet.
Not yet.
Not yet. But you can, like if you're, for locator and route, you need to probably kind of author it through a desktop and then get it onto your device. So that we don't have taking the service offline for geocoding and routing yet.
If you export it from ArcGIS Pro, you can put your routing and geocoding data into the command range. Yeah.
Not through a service yet.
It will come.
It will come soon. Any other questions? If not, thank you very much. Don't forget to give your feedback about the session.
Great. Thanks very much.